1.1c is continuing with our solving equations. We're just taking it one step farther. So we are still using our distributive property. We are still using our inverse operations. However, we are going to be adding two types of solutions. So far we've been ending up with x equals some number. So that is considered one solution. We're going to talk about cases where we could get no solution, or we could get an infinite number of solutions. So let's take a look. First problem we have here is solve for the variable and justify each step. So justify each step, we're going to talk about that a little tomorrow in class. It really just means explain what you're doing, support whatever you decided to do. So we have 4x equals 6x minus 18. Well, notice how I have 4x on this left-hand side and 6x on this right-hand side. So the first thing I'm going to do is get those to the same side of my equation. That's the first thing I'm going to do. Well, how about we move everything to the left side? So since this is a positive 6x, the opposite of having a positive 6x is having a negative 6x. So I'm going to subtract 6x from both sides. 4x minus 6x is negative 2x. Bring down my equal sign. Well, 6x minus 6x, that's just 0, right? That's just 0. Those eliminate each other, which is exactly what we're looking for. And then we still have our negative 18. So we have negative 2x equals negative 18. The opposite of multiplying by negative 2 is dividing by negative 2. So here we have x equals negative 18 divided by negative 2. Well, our negatives eliminate each other, so it's going to be a positive answer, and 18 divided by 2 is 9. So x equals 9. And again, this is a case where we have one solution. There's one number in the entire universe that works for this problem that we can plug in for x and have this be a true statement and equivalent equation. All right, let's keep going. So solve for the variable. We have 5 times 2x minus 3 equals 7x plus 6. We have a lot of stuff going on, so let's just take it step by step. Well, immediately when I see these parentheses, I think of the distributive property. So let's start there. We have 5 times 2x, which is 10x, and we have 5 times negative 3, which is negative 15. So we have 10x minus 15 equals our 7x plus 6. Well, this looks a little bit better, but notice how we have x's on either side, and we have whole numbers on either side. So let's go ahead and combine those. I'm going to move my 7x here, so I'm going to rebalance my equation. So I have 10x minus 7x is 3x. I still have my negative 15. I haven't done anything with that yet. These eliminate each other to become 0. So I just have that positive 6 on the right-hand side of my equation. Well, 3x minus 15 equals 6. Let's go ahead and move that 15. So the opposite of subtracting 15 is adding 15. Well, again, these eliminate each other to 0. So we have 3x equals 6 plus 15 would be 21. The inverse of multiplying by 3 is dividing by 3. 21 divided by 3 is 7. So x equals 7. And again, since x equals 7, this is our one solution situation. So we're just combining everything we've been talking about the past couple days here. Here's a similar problem. 3 times 5 minus 2w equals 10 minus 6w. Notice how our variable is w instead of x, but we're still going to solve for w just as if it were x. So let's do our distribution. 3 times 5 is 15. 3 times negative 2w is negative 6w equals 10 minus 6w. Well, I've got w's on either side, so let's go ahead and combine those. I'm going to add 6w, add 6w. So our 15 just comes down. We haven't changed that at all. These eliminate each other to 0. It's equal to 10 negative 6w plus 6w. Well, that eliminates to 0 also. So what we're looking at is just 15 equals 10. So ask yourself, does 15 equal 10? Hopefully you said no. So since 15 does not equal 10, 15 does not equal 10, this is never, ever, ever going to work out. This equation will never be balanced, right? There's nothing you could plug in for W that could make this equation true. So this means we have no solutions. No solutions. So that would be our final answer for this problem. Next problem, we have 4D minus 5 equals D minus 5 plus 3D. So we have a lot of stuff going on. Let's just start by combining all of our D's, right? All of our variable D's. So over here, I'm just going to leave my 4D here for a minute. 4D minus 5 equals, well, here's 1D plus 3D. Well, 1 plus 3 would be 4. We just have 4 D's. So we have 4D minus 5 equals 4D minus 5. So looking at that, maybe you kind of have a guess of what our answer is going to be, but let's follow this to the end. I'm going to add 5 to both sides. Well, we have 4D, negative 5 plus 5 eliminates to 0. Negative 5 plus 5 eliminates to 0. So we have 4D equals 4D. Here's our inverse of multiplying is dividing by 4. So we end up with D equals D. Well, that's always going to be true no matter what we plug in for D. So we could plug any number in the world into here. D could equal 4, and 4 would be equal to 4. D could equal 1,003/4, and 1,003/4 would be equal to 1,003/4. So we could pick any number we wanted. So since we can pick any number we want, we have infinite solutions. So that would be our final answer, infinite solutions right here. All right, so we've seen our one solution where x is equal to some number, our no solutions where what you get is ridiculous, it makes no sense at all, and we've seen our infinite solutions where you get something equal to itself, which could be a variable equal to a variable, it could be some number equal to itself, such as 4 equals 4, or you could end up with 0 equals 0. So anytime you see anything like this, that is your clue. That's how you know it's going to be infinite solutions. For this next problem, I'd like you to pause the video and see if you can work it out for yourself. Well, let's combine our 4D minus 4D. Well, 4D minus 4D, right? That is like saying you have $4 and then you spend $4, so that just becomes 0. So you have 5 equals 8. Well, is 5 equal to 8? No, it is not. So this is another no solutions, and that would be our final answer. One problem left. Again, it'd be a good plan to pause the video, see if you can solve this one for yourself. Let's start off by distributing. 2 times 5 is 10. 2 times negative 3w is negative 6w plus 6w equals 10. Notice how after I did my distribution, this other half of my equation, this plus 6w equals 10, it just stayed exactly the same because I haven't done anything to change that yet. Well, let's combine these w's, negative 6w plus 6w. Those eliminate each other. So we have 10 on the left-hand side equals 10 on the right-hand side. Well, 10 is always equal to 10 no matter what. So we have infinite solutions. And that is our final answer for this problem. And remember, infinite solutions means you could pick any number you wanted, and that would work out for the equation, right? It would be a solution for the equation, something you could plug in, and the equation would still make sense. Just to sum up, we're still solving equations by isolating the variable and using those inverse operations, but we learned about these two special cases where we have no solution or many solutions, which we're going to call infinite.